Hey there, today we're looking at soil chemical properties. So we will be finishing our challenge lab today, looking at my calendar here, finishing it on Friday, and then we will be starting into soil test on next Tuesday when I see you again. So today we're going to look at chemical properties. Monday you're going to look at fertility, which all have to go with soil test. So let's dive in. You should be taking some notes off of this as there will be some review, maybe quiz or something in your near future. So the importance of soil chemistry, why do we care what the chemical properties are of the soil? Well, crop yields is a huge part of that. And that crop could be a garden, it could be a field crop, it could even just be your grass. We want high productivity, but we also need to make sure that we're protecting the soil. And we need to look at the solids, liquids, and air ratios and see, because those affect productivity. Why does the surface soil change so rapidly? Answer that question. Well, some of the reasons I have is surface soil is where we're adding fertilizers for our crops. So that's where it gets added to. That's where it's getting pulled from. Those nutrients are leaving the soil whenever the roots are in there and sucking them out. Erosion, that's what our challenge is looking at. So it's eroding away the soil that has the nutrients. And then weathering, weathering is not necessarily just climate, but weathering can be the temperature, it can be the amount of humidity, it can be water, the lacking of it or the excess. It could also be insect activity. So warmer temperatures are going to cause more insect activity because they're more likely to move around at that time. So clay particles, kind of jumping into our particles here, they are silicates, meaning that they're made of silicone and oxygen. There's also aluminosilicates, and they obviously include aluminum. These are important for soil chemistry. They make up 85% of the Earth's crust, so it's a little bit of importance there. Cation exchange capacity. So if we think back to physical science or even I got tripped up there. Chemistry, we've heard of anions and cations. Well, we look at cation exchange capacity. Well, let me turn my lights back on. Exchange capacity, we're looking at the ability for the soil to hold onto and to exchange certain cations. Oxygen, silicon, and aluminum basically help determine this for the majority, the major part there. So what are cations? Kind of going back to physical science, we have atoms, smallest portion of an element. We have ions. Atoms have their charged ions or charged electronically, and those are the ions. And then they're either positive or negative. And positive charged ions are cations, negative are anions. So basically we're looking at the exchange of these ions. Calcium, magnesium, potassium, and sodium are all bases or alkaline. Hydrogen and aluminum are acidic, and they are cations. Micelles are negatively charged solid particles composed of clay or organic matter. So we're kind of getting some basis of vocab here. I know this is a lot of just, terms. Where are we going with this? Well, micelles exchange acids for bases. That's what switches out. And they do this because of the chemical attraction of bases is higher. So they're pulling things in higher. Sites are always occupied with cations, and those in the water surrounding the soil particles and in the pores exchange with the acid bases. So they switch out in exchangeable cations. Here it kind of shows a picture. You can see there's some sodium, some chlorine, and our chlorides. Sodium is positive, chlorides is negative, and then they're coming out. You have hydrogens, and you have hydrogen oxide, which then form to make H2O. So what does the CEC tell us? Well, soil, minerals, weather, and to be released, they have to weather. Therefore, they are available to the plants. The excess amounts are leached out in the groundwater, so they're taken out and they're lost. Cations exchange creates equilibriums, which affects the ease of root nutrient absorption. So basically, cations determine how easily the soil will release those nutrients to the plant. Organic matter can help your cation exchange capacity, because we go back to what 2 slides back, it kind of shows where organic matter is. I lost my spot where that was at. Oh, micelles are composed of clay and organic matter. So it really plays a role. So a soil test, we can calculate that CEC, and then we can compare those to figure out our soil management. So this kind of gives you an example. If you have 390 pounds per acre of potassium and you have 240 pounds per acre, or is present and per acre is needed, you've got 360 pounds of magnesium is present, 288 is needed, 2,400 pounds of of calcium is present, 3,600 is needed. What do you need to do to create a good soil? So if the first number is how much is there, the second number is how much is needed, what do you need to do for this case? If you're answering that, then we're looking at, if we have 390 pounds of potassium and we only need 240, do we have to add any? No. This would be the results of that test that you did, your soil test. If you need 360 pounds per acre of magnesium and we only have 288, what does that tell us about that magnesium? It tells you to add it, right? So we're going to need to add magnesium. Looks like we also need to add calcium. So those are two things we need to look at sources and how can we add them. Sometimes we can get them from the same source. Sometimes you have to do something mixed. Next up, we have pH. So the pH scale runs from 0 to 14. Which one is alkaline and which one is acidic? And where is neutral? Well, neutral is 7, right down the middle. Rarely do we have a 7.0 in our soils, but you maybe slightly over or slightly less. But as you go away from that center of the scale, the 7, you start to get more acidic, more alkaline. As you go down towards 0, you are more acidic. As you go up towards alkaline, or to 14, you're going more alkaline. Alkaline is a more specific term for a product that is basic, or we used to think of like acids and bases. Well, they're alkaline. Missouri soils, we're going to range anywhere from 4.5 to 8.4. However, a lot of our soils are running in the 6.5 to like 6.2. So you're in the slightly acidic side. What does the 7 mean? Well, it's actually, that number is an exponent. And so it's really how many hydrogen positive or hydrogen cations that there are present. And so we just, as you can see, it's like 1.0 times 10 to the negative 7. They just drop the negative, and that's what that actual number, how they derive it. How do we determine pH? You can do 2 different ways. You can do water soluble and you can do salt. Salt is usually more specific and it's a better method. However, the quick method can tell us a lot. We're going to be doing the quick method in class, which is water. If we were going to do salt, the easiest way to do that is to send it off to a lab, and you pay like $30 and they will tell you everything and anything you want to know about your soil, more than just pH. Why do I care what pH is? Well, it's going to give us an idea of what the balance of nutrients are. It's going to, if the pH is off, it's going to limit a lot of those nutrients. So they could be right there, but you can't get them out. Like you can't get it out of that into the soil. The roots cannot take it up. It also tells us if we need to adjust it. So if we need to adjust pH, if it's too acidic of a soil, we need to bring it down to be more, or I'm sorry, bring it up in numbers to be more alkaline. We're going to add lime. If it is too alkaline, then we're going to add sulfur. In Missouri, because we have a lot of plants growing and just where our soil tends to fall naturally, we usually have to add lime to our fields and our soil if we're going to do add anything. Certain parts of the world, they actually have to add sulfur to it. So like I had a college professor that used to teach at a university in Texas, and he was saying that their baseball field would not grow any grass on it. And the turf management people, the grounds guys were like, what is going on? They kept reseeding it. They even had people sit out there overnight trying to figure out, well, are the deer coming in and eating it? You know, what's going on? Nothing was happening. And finally, they came to the soil professor and were like, hey, you know, we got any ideas? And his first question was, have you done a soil test? And they all kind of looked at each other and said, no. So they went out and did a test. And what he found was that their soil was extremely acidic, too alkaline. They had to bring it more acidic. So they actually put sulfur on it. And as soon as they did that, it grew without any problem. So it was a matter of the pH was just enough off that it wouldn't allow it to grow. So one little thing can change your whole productivity, like at that quick. It can be something very small. You don't have to work that hard to correct it. So when we do our soil test, one of the things you're going to do is pH. The soil test is very easy. You just simply read through the directions and follow them step by step. If you had my 8th grade class with me, you've done this before. We're using the same test kits. These are available at Lowe's, Home Depot, Amazon, Walmart, all those places. But it's very simple. But we're going to figure out the pH of our soil, see if there's anything that we need to change with it. We're also going to test for N, P, and K, so nitrogen, phosphorus, potassium, because those are the 3 most needed elements whenever we're looking at plant growth. So go ahead and wrap up your notes here, and I will see you on, I guess it's Monday. Have a fabulous weekend.